Today, I'll be talking about extensions to Neurodata Without Borders. And so, just to give a brief overview, I'll be talking about what are extensions, when you would use extensions, how you would write an extension, and how you would share an extension. And so, we already kind of briefly talked about this. Alessio brought up the extension proposal process that the technical advisory board is involved in. And it sounds like we have some people that are already using some extensions. And so now we'll go into a little bit more detail about that process and sharing an extension with the community or making a new one. And this is going to be more an introduction to the topic rather than a comprehensive guide so that you're familiar with some of the terms and know that this functionality is possible in the future. So most of what I present in this talk today is going to be found on this NWB overview website. And so if you go to the website NWB overview and click extending NWB, this will cover a lot of the topics that I talk about here today, but in more detail. And so NWB, as you all have learned through many of the talks here today, covers lots of types of neurophysiology data, including metadata, experimental subject data, design, acquisition, and behavior. And so the question is, these neurophysiology experiments are often really complex, and there might be new data types or modalities that aren't already covered by our core standard. And so, for example, some of these data types might be if you have a brand new acquisition system or a really specific type of acquisition system and you want to save specific properties about it, for example, about a probe or a microscope. You also might be working with a pre-processing tool that you want to encode information specific to that pipeline, for example, in spike sorting or pose estimation training and model parameters. Another case that can come up is if if your lab has a really specific experimental design. So for example, you might have a custom maze structure or just a very customized task design, and all that types of metadata are really important to you, but aren't maybe common to a lot of other neuroscientists in the community. And then finally, another one can be that neuroscience is a pretty rapidly evolving field, and there are lots of new data types and modalities and methods that are coming out. And for example, pose estimation, fibrophotometry, and functional ultrasound aren't yet supported by the core standard, but we want you to have ways to start to support or start to be able to save this kind of data. And we want NWB to be able to support this types of data as they're emerging. And we basically, NWB can evolve with the neuroscience experiments as well. And so this is where extensions come in for all of these new different types of data types or new data types and modalities. And so extensions allow you to define your own data types, and it can be integrated with the API and then shared with the community. And so like in that example I gave previously, if there's some awesome new microscope that you have that generates microscope specific data structure, you can write an NWB extension for that microscope data structure and then share that extension. And then other scientists that are also using that new microscope can build upon your work or expand upon it and add it to their own NWB data. And as I think one of the questions earlier was, how does this work or how does it get bundled with your data? And so the extension is basically cached in the NWB file, and so that other people can read new data types without having to pip install or download the extension separately. And so in the work of the NWB team so far, there have been about 25 extensions that are made by the community for different reasons or for ourselves as well. And so there's this NDX catalog that you can go to. Oh, the link doesn't work, but you can go to this extensions catalog and it will list about 10 extensions that have been publicly shared already. And so here are some of the examples of what those extensions are. And so if you are coming across in your data and you're thinking you might need to create an extension, you can check the catalog to see if one exists. And then in that way, you can also collaborate and expand upon that one. So I think someone mentioned NDX Sound is one that is published in the NDX catalog. I'll give you a second to kind of read some of these different ones that cover different data types, odor, events, snares. And there are also several unpublished data extensions that you can find as well that haven't gone through the full publishing process. or are currently in development. So extensions are great for covering all of these different data types that aren't covered by the core NWB standard. And so the next question is, how do you write your own extension? And so at its core, extensions are kind of defined in the same schema language that the core NWB standard uses. And so the NWB schema is the set of YAML files that look like this. And so basically we're defining a bunch of groups and data sets. And so you can think of those as folders and arrays. And so groups can contain other groups, and then data sets or attributes and links. And it's like a folder file system on your computer where you have folders with files and they all have their own properties and attributes and shortcuts. And so data sets can also have different data types like int or float, and you can specify that they're a specific dimension or restrict them in different ways like that. And so what these YAML files do is they define the rules for how different types of data should be organized for a particular neurodata type. And so in this example that I'm showing you here, we're defining this group time series. And so this extends this neurodata or NWB data interface type. And so we have this general description that it's a general purpose time series. It has a data set called data and a data set called timestamps. And so timestamps is then going to have these additional attributes, for example, unit that's set to a default value of seconds and it's text. And so, yeah, unit is a text value. Or maybe the data has a specific data type, for example, volts or meters, or unit type that's volts or meters. And so then to combine all of these different related types together and to prevent naming conflicts across the NWB ecosystem, these will all then belong to this NWB namespace. And so this namespace file is defined in this core namespace.yaml here, and it's going to kind of collect all those different neurodata types that you have for a specific extension, or in this example, for the core schema. And so the core NWB schema has over 60 data types, and extensions can build upon those existing data types to define new types. And again, it's written in the same kind of schema language and structure here. And so I just want to start with an example. Let's say you want to define a new neurodata type tetrode series. And so a tetrode would be a specialized type of electrode that has 4 twisted wires. And so it's would, in this case, inherit from our existing electrical series data type that's part of the core standard. And we'll just add, all that we'll add to it is this new required attribute that's the tetrode ID. And so that's going to, it's an int value. And we're going to put this new tetrode series neurodata type in our NDX tetrode namespace. And so in this namespace YAML file, we can also add additional information like who is making this extension, the contact information, the version information. And this, if you're familiar with object-oriented programming principles, it'll follow that similarly. So this tetrode series is going to inherit all the attributes and data set that belong to the electrical series neurodata type as well. All right, so that was an example YAML file to show how you might start to set up your own neurodata types. But we do have this tool, NDX template, that can make this process a little easier for you, since writing your own YAML files can be kind of tedious and error prone. And so this is a tool GitHub repo that you can use, where you can use the cookie cutter command line tool to download and run the template, and it'll start to set up your extension for you. And so let's see if this link works. Yes, yeah. And so there's additional details in the README for how to get started, and you can follow these if you're interested. And so I'm going to walk through a brief example of what this process might look like. And so with cookie cutter, if you haven't used it before, what you'll do is type in the command line cookie cutter, and then we have NWB extensions, NDX template, and it'll give you these prompts to start to fill out your new extension that you want to make. And so you'll call, for the example that we created, we have this NDX tetrode namespace. It's going to be a data type to store tetrode data. Again, we can add author, email, GitHub information. And then when we click enter, we'll create this kind of folder that has a skeleton for your new extension project. And so within that directory that you've just created, there is a file that's provided that's a Python script that's a starting point for generating those YAML files that I showed earlier. And so what this function does is it creates the namespace YAML file based on the information that you provided in the cookie cutter prompts. And so the cookie cutter will already kind of fill out the basics of this form. And yeah, this is updated, but imagine my name and information and all that information I filled out before was here. And so this will get you started with creating your own extension YAML files. And so here, for example, this file got automatically generated and we'll define this new group tetrad series data type in a similar manner that we did before. So we'll have tetrad series, it inherits from electrical series, it's a data type to store the recordings. We can add all of that same information here, including our new attribute, which is going to be the tetrad ID, and it's going to be of int data type. And so together, all this code is going to generate those YAML files that I showed you before. And so in this way, you can kind of take advantage of the existing documentation and avoid any errors and make sure everything's working properly. After you've generated your own extension, we then recommend that you publish it on the Python package index so that you can pip install it and so that other users can use it as well. And so that was creating the YAML files and the schema for your extension. What you might also want to do is define a new Python interface or API class that's associated with your extension so that you can interact with your data when you load in specific ways when you load your NWB file. And so you can automatically generate this, a Python API class for your extension using this. There are two options here. You can automatically generate the class using this get class method. And so this will generate a new class for the data type, complete with all the constructors and getters and setters based on the contents of your data type. Now, this is generated based on that schema file in the extension specification. So if you do ever make changes to that, it is going to automatically change your code, or you're going to need to automatically change your code as well. And so this might be a little more complicated, which is why we also have the second option, which is defining your own custom API class. And so here we're defining our own tetrad series class that'll be associated with the extension we've created. And so this is recommended if you maybe need to add a little bit more functionality, or if you want a stable API that'll remain consistent even if you make changes to the schema. And so once you installed your extension, it becomes pretty easy to use and incorporate with the rest of PyNWB. So here we're importing PyNWB, and then all we have to run is from NDX tetrad, our extension, import tetrad series. We'll create an instance of our tetrad series class, and then we can add it to our acquisition, just like we add our normal electrical series. And so there's a lot of magic going on behind the scenes, but in theory, writing the file and everything after that is pretty much the same. And the extension will be saved also and cached in the NWB file. And I think load namespaces equals true is the default argument now, so you don't even have to put that. You should be able to just write as normal. Write and read as normal. All right, so then after you've created your extension and maybe you have it now on GitHub, but it's technically not published or shared with the community, and so only you in theory would be using it. And so after you create a new extension, we recommend that you publish it and make it accessible via the NerdData Extensions NDX catalog. And so this is going to consist of a bunch of GitHub repos that have the metadata about the extension, what it does, how to install it, some examples ideally, and who maintains it. And so if the extension supports data types that might be used by someone else in the community, this is great for several reasons. So it makes it easier to find. That way other people are using the same extension and not just making a bunch of different ones each time they need to make a new neuro data type. When you publish it, it's also tested by the NWB team. And so then we know that things work and it meets the criteria for acceptance into the catalog. Like I mentioned, yeah, it encourages a single extension for a particular use case rather than 10 different extensions. So like the microscope example I mentioned earlier, if you started using this brand new microscope and you want to save the data, it's likely that there are other people that would like to save that same metadata as well. And registering the extensions can also simplify the collaboration and review of them for shared use cases. And so what this review process looks like is the catalog admins will review the extension to see if it uses language correctly, has useful and readable documentation, it's not a duplication. And then a new record repo will be automatically generated in this NWB extensions GitHub organization, but the creators of the extension are still added as admins, and so you'll retain ownership and control of that. And so now it's registered and it'll be part of the extensions catalog. If you ever need to update the extension, it would be a similar process as registering, but now you would do all of that work on the new existing record repo in the catalog instead of the stage one or your own. And so that was an example of when you might want to create an extension for a new data type, or how you would create an extension for a bunch of different data use cases. And then another reason you might want to use these extensions is that the core standard will need to be updated and refined over time. And so the question is, how do we integrate new and modified data types into the core standard and the core neuro data types? And so these extensions can be a really good framework because you can serve as a test bed to make changes to the core standard. And so, like the tab said, the key thing is that proposals for changes to NWB usually start with an extension. And so the extension will be the test bed to show this is all going to work, and then we can integrate it with the core standard. And so if it is a change to the core standard, it'll undergo a slightly stricter review process in which you'll have a community review with a group of users and developers and domain experts, and then the core proposal review with the developers and executive board to kind of assess the merits. All right, so that was a brief summary of extensions. Like I mentioned, there's a lot of additional information on the NWB overview website. You can use that NDX template tool to help you create extensions, and so the links are here. Again, once you created an extension, it's great if you can register that to the NDX catalog to make it findable and accessible. And then also definitely check out the catalog to see if there's an existing one that would meet your needs, and then you can collaborate and expand upon that if you do need to make slight changes. And then, yeah, finally, I covered the case of what the extension proposal might look like as well for changes to refining the core NWB standard.